Hello, this video is for IXL 8.A.2. It's titled Divisibility Rules, and the 3-character code for it is Victor Whiskey 5. So, rules of divisibility, what are they and why do we need to know them? Well, a number is divisible. We say that a number is divisible if you can divide it by another whole number. That means a non-decimal number, right? And so why do you need to know this? Well, it comes in real handy whenever you're trying to do prime factorization. It comes in handy whenever you're trying to simplify fractions, those type of things. So, and we're going to be doing some prime factorization later on. So that's why I've elected to go ahead and include this particular activity in the activities that are assigned. So, the rules of divisibility. So, if a number is divisible by 2, well, if the last digit's even. And this makes sense, right? Because all even numbers will divide by 2. We can get to every single even number by counting by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, etc., right? So if the last digit is even, then it's an even number, and all even numbers are divisible by 2. The only even number that is a prime number is 2. So, is it divisible by 3? Well, the rule of that, this one's kind of cool. If the sum of the digits is divisible by 3, then that number is divisible by 3. Like, let's say 90 and what's a number greater than 9 that's divisible by a number greater than 9. I'm trying to think of 90. Okay, a number greater than 9 that's divisible by 3. There we go, 15. 9 plus what is 15? Well, 9 plus 6, right? So 9 plus 6 equals 15, and 15 will divide by 3, therefore 96 would divide by 3 also. So that's what we mean by that rule, and the rule for 9 is pretty much the same way. So if you can add up the digits and the sum of those digits is divisible by 3, then that very number that you got those digits from, that number is divisible by 3 as well. The rule for 4 is that if the last two digits are divisible by 4. So this one's kind of handy for numbers that are 100 or higher, right? So like if you had a number like 94, right? Is this divisible by 4? Well, you're going to have to divide the whole number by 4. But let's say you had 1094. Well, you could find out if 1094 was divisible by 4 simply by just looking at the last two numbers. The reason for that is if you think about it, we can always count by 4s to get to 100. So we always know that the hundreds place is going to be divisible by 4. That's that tens place and that ones place together that we're not sure of, and so that's how you would do that. And also notice that whenever you count by 4s, 4, 8, 12, 16, 20, all those are even numbers. So any number that 4 will go into is going to be an even number. So if it's an odd number, you really wouldn't have to worry about checking it. You already know that an odd number is not divisible by an even number. And that's going to hold true for the other even numbers such as 6, 8, and 10 as well. So if the last digit, 5, the rule 5, I'm reading without telling you which one I'm doing. So if the last digit is 0 or 5, and that makes sense too, because if we count by 5s, 5, 10, 15, 20, and so forth, notice that all of these end in the ones place. Whenever we say that they end, or we refer to the ones place as the last digit, we're saying that ones place is either a 0 or a 5. So rule for 5 is the last digit is either a 0 or a 5. For 6, this is an interesting one. 6 is if it's divisible by 3 and 2. So if the rule for 3 and the rule for 2 worked, then it will divide by 6. And this makes sense also because what is 3 times 2? 3 times 2 is 6. So that's the rule for 6. Rule 7. What's the rule for 7? Now, 7, usually I just tell students you need to check it. Just try to divide it by 7 and see if it'll work out. But this one's kind of crazy. You double the last digit and subtract it from the number made by the other digits. The result must be divisible by 7. So let's just pick a number. 1,394. And let's try that, see if it's divisible by 7. So we want to double the last digit. So the last digit's 4. So that's 8, right? Double 4, we get 8. So double the last digit and subtract it from the number made by the other digits. Well, the other number is 139. So let's go ahead and subtract it. 139 minus 8 is going to be, what, 131? And is this divisible by 7? Well, I guess we could take this 1 and double it, right, to get 2, and remaining is 13, right? So then we could go ahead and do 13 minus 2, and that's going to be 11. And will 11 divide by 7? No, it won't. So the original number, 1,394, won't divide by 7 either. That's kind of an interesting rule. It's for some, it's kind of a tough one to remember. As a matter of fact, I usually don't remember that one. All right. On the next one, 8. 8's kind of like 4. If the last 3 digits are divisible by 8. So in this case, remember 4 is at the last 2 digits. And the way I remember this is that 8 is twice as much as 4. So whereas with 4 you have to look at just the last 2 digits, but with 8 you have to look at the last 3 digits. Well, that's not going to help too much if you got a number like 72, right? There's only 2 digits. Even if you had 472, you would still have to just try to divide it by 8 and see if you get a whole number up here. That means a non-decimal number. Okay, so that's the rule for 8, if the last 3 digits are divisible by 8. And the rule for 9, like I said, is similar to the rule for 3. If all the sum of the digits equals a number that's divisible by 9, and that number is divisible by 9. For instance, think of a number that's divisible, where if we add them up, we get a number divisible by 9. Like 18. 18 is divisible by 9. So if we had 3, that's 6. And if we throw a 4, that's 10. And an 8. So we just say 3,348. Is this divisible by 9? Well, 3 plus 3 plus 4 plus 8. Well, that's 6, plus the 4 is 10, plus the 8 is 18. Is 18 divisible by 9? Indeed it is. So 3,348 would be divisible by 9 as well. So that's the rule for 9. And then the rule for 10 is a really super simple one. That is if it ends in a 0. Because whenever we count by tens, what do we get? We get, what, 10, 20, 30, so forth. All of them end with 0. So that's all the rules of divisibility for 2 through 10. There is a rule for 11, and there's a rule for 12 also. But for the most part in this activity, I'd say just kind of check it. And also, if you think about 11, start counting by 11s. You kind of know those. The numbers are the same, right? 22, 33, 44, 55. Until you get past 9, 99. And then 10 is 11 with a 0 on the end. So that's 110. And then 11 times 11, if you're good at memorizing your times tables, one of the things that you try to memorize is that some number times itself. And 11 times 11 is 121. So with that, let's go ahead and start looking at some of these. It says to select all the digits that make this statement true. And so we want a number that's divisible by 2. Well, the rule for 2 is that the last digit has to be, what, an even number, 0, 2, 4, 6, or 8. Well, so 2 would work because it is the last place that they're asking for. 6 is an even number, 4 is an even number, and 7 is an odd number, so that one won't work. So the first 3 are correct choices. And the next one is 4,491,840 divisible by 10. Well, the rule for 10 is the last number is a 0. Well, indeed, the last number is a 0, so we'll say yes, this is divisible by 10. On the next one is 77,416,369 divisible by 5. Well, the rule for 5 is the last digit has to be a 0 or a 5, right? Is this a 0 or a 5? Indeed it is not, so it is not divisible by 5. Here it says to select all the digits that make this statement true, and so we got 3,772,660 something, right? The last digit. Well, we know that it has to be a 0 or a 5, so we're only going to select 0 or 5, and there is a 5 there, so that would be our only correct answer. On the next one, the rule of 3. So the rule of 3 is add up all the digits. If the sum of those digits equals a number that's divisible by 3, then the original number that we got those digits from is divisible by 3 as well. So we need to go ahead and add all these up. So we would have 1 plus 5 plus 9 plus 9 plus 2 plus 4. And I always like to use a strategy of finding numbers that work together well, like 9 and 9 is 18. And then if I pull that 2 down there at the 18, I get 20. So I've taken care of the 2 9s and the 2. Now look here, I got a 5 and a 4, that's 9, and one more would make 10. So I need to add another 10 to that. I end up with 30, so 30 is the sum of all those digits. Is 30 divisible by 3? Of course it is. 10 times 3 is 30. So since the sum of all those digits will divide by 3, then the number that we got all those digits from will divide by 3 as well. So this answer is yes. On the next one, they want you to type a digit that makes the statement true. They're wanting to know, is it divisible by 3? So we've got to make this value divisible by 3. Well, again, the sum of all those digits have to add up to something that's divisible by 3. So we have one that we don't know. We'll just call that x for now, the unknown number. So we know that we have 2 plus 5 plus 1 plus whatever x is plus 0 plus 6 plus 4 should equal a number that is divisible by 3. Let's put together some easy stuff. Look at there. We got 10 right there. 6 plus 4 is 10. The 0 is not going to change it. We're still at 10. And then over here we have 2, 5, and 1, which 1 and 2 is 3, plus 5 is 8. So we end up with 18. So we still have to do 18 plus x equals some number divisible by 3. Well, 18 is already divisible by 3, right? We know that because 8 plus 1 is 3, or 8 plus 1 is 9, and 9 will divide by 3, so we know that 18 will. So this number could be 18. And if that were the case, what would x be? X would be 0, so we know 0 works. But what else might work? 18 plus x equals what? Some number. We'll go 3 more past 18. 21 is also divisible by 3. So 18 plus what number is 21? Well, hopefully you're saying 3. And then we could try again. 18 plus, is there another number that would work? Well, 21 plus 3 is 24. So we get to 24 counting by 3s. So 24 is divisible by 3 as well. So 18 plus what number equals 24? Well, that number is 6. Can we get another one? 18 plus some number x equals, and 3 more from 24 is 27. And so what number would that be? Well, 18 plus 9 would work. And then if we go one more, 18 plus x equals, well, let's add 3 to 27. We get 30. And that would be, x would have to be what number? It would have to be, what, 12, right? Well, that's not going to work because we can't put 2 digits in there, and 12 is a 2-digit number. So we stop there. So 0, 3, 6, or 9. If you were to type any of those into that box right there, it would give you a correct answer. IXL set up to accept any of those 4 numbers because all of them would make that a true statement. On the next one, divisible by 4. That rule is look at the last 2 digits. So the last 2 digits make up the number 84. Now I could think of the fact that 4 will go into 40, and 40 plus 40 is 80. And then another 4 would give me 84. I could do some mental math like that and realize, okay, the answer is going to be yes. Or if you really had to, you could just go ahead, try to divide 4 into there, and you would see that indeed 4 goes into 4 once, and it would be 21 times. Here we have select all the digits that make the statement true. So for the rule of 4, it's the last 2 digits. So we have a 1 and a 2. Is 12 divisible by 4? Indeed, that is correct. A 1 and a 4. Is 14 divisible by 4? No, it is not. So that one doesn't work. 4 won't work. What about a 1 and a 6? Is 16 divisible by 4? Indeed it is. 4 times 4 is 16. So 6 would work. And what about 18? Can I count by 4s and get to 18? Indeed I cannot. So 8 would not be a correct answer. Now we have the rule of 6. Remember, the rule of 6 is if 2 works and if 3 works, then 6 works. So rule of 2, even number. Good. It's an even number, so the rule for 2. 2 checks off. what about the rule of 3? We need to add the digits together, right? So let's find some that go together well. Here we got 5 and 4 is 9. And so that's 9. And the 6 plus 4 is 10. Right? So put those together, we get 19. And we still have to add the 2. So we end up with, what, 21? And will 3 go into 21? Indeed it does. So the rule of 3 works also. So since 2 works and 3 works, then 6 also works. On the next one here, we have 976,677. Is it divisible by 6? Well, let's try the rule of 2 first. 2 is the last digit has to be an even number. 7's not even, so we can already rule this one out. It doesn't work. We don't even have to try the rule for 3. Next one, type a digit that makes this statement true. And the number is 95,482,650 something. X is what we need to know. Well, they want to know divisible by 6. Well, one thing we know is that 2 has to work and 3 has to work. Well, in order to make 2 work, it can only be one of 5 different numbers, right? 0, 2, 4, 6, or 8. So we know it has to be one of these so that 2 will work. The question is, what numbers can we use to make 3 work? So with that said, let's go ahead. Remember, rule of 3, add them up. So I end up with 9 plus 5 plus 4 plus 8 plus 2 plus 6 plus 5 plus some number x. Well, if I start adding all these together, let's try to make some nice pairs here. 8 and 2 is 10. 5 and 5 is also 10, so I'm up to 20, right? And, oh, look at here, 6 and 4, that's another 10, so now I'm up to 30, right? And the only thing I have left is the 9 left over, so that's 39, right? So I took care of the 9, check. Yep, took care of everything. So 39 plus x equals some number that's divisible by 3. So we're going to have to go up above 30, right? Well, get this. 39, 3 plus 9 is 12, right? So 12 will divide by 3. So that means 39 is going to divide by 3. So I'm already there. I could just add what? X could be 0, right? 39 plus 0 would be 39, right? If this were 0, and 39 is divisible by 3. So 0 is an even number. That would work. Let's do 39 plus 3 is 42, right? 42 will divide by 3. 39 plus what number is 42? Well, that number would be 3, right? So for rule 3, 3 could do it. And let's go ahead and go on. 42 plus another 3 would be 45. 39 plus what number is 45? Well, 39 plus 6. So 6 would work. Let's go 3 further than that. 45 plus 3 is 48. 48 will divide by 3 as well. And so 39 plus what number equals 48? Well, that is 39 plus 9. And now we know that if we try any other number, if we go up another 3 to 51, we're going to get a 2-digit number. So we can pretty much stop there. So we're looking for a number that's going to work for both 2 and 3. And notice that we have a couple numbers, it looks like. We have 0 in both sets, and we have 6 in both sets. So either 0 or 6 would work, either one of those. Okay? On to the rule of 8. So the rule of 8 is the last 2 digits, right? So we just have to take the last 2 digits and see if they are indeed divisible by 8. Well, these make 81. Can I get to 81 counting by 8? Probably not, because 8 times 10 is going to give me 80. And then the next, another 8 would put me at 88. And I would have jumped right past 81, getting to 88. So the answer is no, that's not going to work. Okay, let's look at the next one. Which digit makes this statement true? And we're talking about the rule of 8 for this one here. Well, it's 27,468,100 and something in the tens place with the 6 in the ones place. Well, we know the rule of 8 is the last 3 digits, right? The rule of 4 is the last 2 digits. Rule of 8 is the last 3. So I could plug a 4 in there, 146. And the question is, will it divide by 8? So 8 will go into 14 once, and that'll give me 8. 14 minus 8 is 6. And bring down the other 6 there, and will 8 go into 66? Well, 8 times 8 is 64, and that's 2 before 66. So the 4 is not going to work. It cannot be 146. So we can rule out the 4. What about 176? Let's try that. Let's try to divide that by 8. So 8 will go into 17 twice. 8 times 2 is 16. And let's subtract. We get 1. Now let's bring down that 6. And 8 will go into 16. Oh, there we go. 8 times 8 is 16. And so we'd have 16 and nothing left. So the 7 would indeed work. So let's go ahead and, just for practice sake, we'll go ahead and try the rest of them. So if I put in an 8 there in the tens place, 186, let's divide it by 8. 8 will go into 18 twice. That gives me 16. And then subtract. And I get 2. Bring down the 6. 8 into 26. Well, I know that 8 times 3 is 24. And the next 8 is going to take me to 32. And I jump right past 26. So if 8 were in the tens place, that would not work. And we have one more to check out. I'm going to guess it doesn't work. If I put a 6 in right there, 166. If I had a 6 there in the tens place. So let's try to divide it by 8. This ain't going to work out. Check this out. 8 times 2 is 16. So it'll go into 16 twice. And that would be 0. Bring down the 6. 8 will not go into 6. So that would be 0. And we'd end up with some decimal number. So 6 isn't going to work as well. So the only one that worked is 7. Let's look at the rule for 9. Rule for 9. So 9 is add all the digits up. And if the sum of all those digits is divisible by 9, then the number that we got all those digits from is divisible by 9 as well. So let's go ahead and add all these up. I'm not going to write them out to the side. Hopefully you kind of get to where you can do the same thing here. Check this out. 6 plus 4 is 10. And then I have 3 and 2 is 5. So I'm up to 15. And then I have 1, 2, 3 1s. So 15 plus 3 is going to be 18. And 18 will divide by 9, right? 9 will go into 18 twice. So the answer is yes, this will divide by 9. Which number makes the statement true? Again, we're still doing 9 rule, so we have to add all these up. On this one here, I'll go ahead and work that one out. Well, actually, let's not. Let's go ahead and because look at all these 5s in there. Wow. 5, 10, 15. So I've got 15 there. Plus 9 is going to give me 24. And then if I add, oh, look, here's another 9. So that's going to give me 33. And then I got a 2, and I have a 4 also. And 2 plus 4 is 6. So 33 plus 6 is 39. So I need to figure out what digit could I put in right here, right? And I'm just going to go through and make sure I did that correctly. 5, 10, 15. That's 15. 9 and 9 is 18, plus 2 more is 20. And then add 4, right? Add another 4, and I should end up 9, 3. Yep, indeed, I got it right. It's 39. Good. So I'm looking for 39 plus some number equals some number divisible by 9. So what if this number were 1? Then we would have 40. Will 40 divide by 9? No, it will not. So because 4 plus 0 equals 4, and 4 won't divide by 9. What if it were a 2? 39 plus 2 is 41. Will 41 divide by 9? Well, we can use that same trick of adding the numbers together. 4 plus 1 is 5. 5 won't divide by 9. So 41 won't divide by 9. If 41 doesn't divide by 9, then that whole number won't divide by 9 either. So 2 didn't work either. What if we make this a 6? 39 plus 6 is 45. I think we have a winner. 44 plus 5 equals 9, and 9 will divide by 9. So 45 divides by 9, right? 9 times 5 is 45. So that means that 6 would work. And I don't think the 3 is going to work. We could check that one out. We could do 39 plus 3, and we're going to get 42. And 42, 4 plus 2 is 6. I'm writing the answer down first. 4 plus 2 equals 6, and 6 won't divide by 9, so 42 won't divide by 9, and 42 won't divide by 9, then it doesn't work for us. So it turns out to be that this one's not any good either. 6 is the only correct answer. On the next one, oh, you're going to get word problems after you get past the 9s. So last year, Good Food Cereal Company produced this many boxes of cereal. This is the number you're going to have to focus on dividing. The company produced the exact same number of boxes for each type of cereal, so they're being divided into equal parts. So that's what we're looking at, is looking to see, will something divide equally? How many different types of cereal could the General Food Cereal Company make? Select all the possible numbers. So basically, we need to know which numbers will this number here divide by. So if we do the rule for 6, what's the rule for 6? Does 2 and 3 work? Does 2 work? Yep. Does 3 work? Well, let's add them up. We have the 6 and the 6 is 12, and the 8 and the 4 is 12, right? So we have 12 plus 12 equals 24. Will 24 divide by 3? Well, 2 plus 4 equals 6, and 6 will divide by 3, so 24 will divide by 3. So that means this big number here will divide by 3 as well. So 2 works and 3 works, so therefore we know that 6 works. So let's go ahead and say, yep, 6 is good to go. What about 8? 8 says the last 3 numbers, right? Well, the last 3 numbers is 0, 0, 6. So you only really have to ask yourself, will 8 go into 6? Nope, it won't work. So we'll rule that one out. The rule for 3, well, we did 6, and we found out that 2 works and 3 works, so we already know 3 is good to go. We don't have to do that math again. And then finally, what about 5? The rule for 5 is 0 and 5 for the last digit, right? Well, the last digit is 6. 6 is not a 0 or a 5, so we can rule that out. So the only 2 correct answers here is 6 and 3. On the next one, Kathleen is organizing 73,944 nails into a bin at the hardware store. Well, that's probably going to take her a while. She needs to put the same number of nails in each bin without any leftover nails. See, she's got to count out 73,944 nails and make sure there's even number in each bin that she is going to. That's like an all-day project, if not all week. How many bins could Kathleen use for the nails? So, again, here's our number that we're trying to divide, and we need to ask ourselves, will these numbers go into it? So the rule of 3, add them up, see if the sum is divisible by 3, and if it is, then we'll be good to go. And here's the 9 rule here, right? So we already need to add them up anyhow. So let's do that. 7 plus 3 is 10, and 4 plus 4 is 8, putting us at 18, plus 9 is going to give us 27. So 27 is the sum of all those digits. We'll go ahead and erase this and clean that up. So will 27 divide by 3? Indeed it will, because 2 plus 7 equals 9. So 9 will divide by 3. So that means 27 divides by 3, and therefore this number divides by 3. So 3 works. Now let's go ahead and do that 9 one since we are already there. 27, will it divide by 9? Indeed it will, because 2 plus 7 is 9. 9 will divide by 9, and we know that 9 times 3 is 27, so 9 works also. How about 8? Well, it is an even number. If it were an odd number, we wouldn't even have to check it. We just know, okay, that doesn't work. I can't count by 8s and get to any odd numbers. But 8, we're going to look at the last 3 numbers, so 944. And I'm kind of distracted right now because I believe that's a number for a Porsche car. 8 will go into 9 once. 8, subtract, get 1. Bring down the 4. 8 will go into 14 once. 8, bring down the 8. And 14 minus 8 is 6. Bring down the 4. And 8 times 8, 64. So 8 will go in 8 times, 64. And we get to 0. So we know that it's 944 divided by 8 is 118. That is a whole number. So it turns out to be that 8 works as well. And then finally, the last one should be pretty easy. And it is easy because the rule for 2, the last number has to be an even number. 4 is an even number, so 2 works as well. So in this case, all of them worked. All right, so those last ones will be word problems, but don't get too worried about it. You're going to have an easier time solving questions like these than Kathleen is going to have of trying to sort those 73,944 nails into 3, 8, 9, or 2 separate bins with the same number of nails, even though it's just 2 bends. Can you imagine trying to make sure you had the same number of nails in each one? That'd be crazy. All right, so those are all of my examples for IXL 8.A.2 divisibility rules, and good luck with your activity.